Let me start the some technical theoretical knowledge of the acid properties. Okay, so before going to discuss about the acid properties, we need to understand the uh, what I mean is, uh, what is the transaction and what types of transactions we have. So then we can go for the acid properties. So let me go for the thing. MS Paint. Instead of MS Paint, I will go for Notepad only. What is transaction? So the transaction is nothing but a it is a set of T-SQL statement. So the transaction is nothing but a single statement or maybe multiple statement. What is the statement? The statement is nothing but if you write any query, that query we can call like a statement. Like select star from table. This is the one statement. So the transaction is nothing but a set of statement or single statement. Okay. Uh, Using the this statement. Okay. Using the this statement, the data can be insert. Insert is nothing but a write. The data can be a read. Read means like a select. So using the this transaction, the data can be read and write to the table. The table, if you read the table means we are going to read the data from the database. Why? Because inside the database, we are going to keep the data in the table, right? So using the transactions, the every records will fetch or insert from the database. So these transactions are, we have a two types. The transactions are two types. So what are those? What are those? Implicit IMPLI, implicit transaction, and explicit transaction. So the definition is like the transaction is a set of statement. The statements may be single statement or multiple statement. Using that statements, the data can be read or write into the database. So these transactions are two types. That is a implicit transaction and is explicit transaction. So what is the implicit transaction? So when we go on the transaction, okay, when we writing the statement, when we writing the statement, we are not going to provide any begin and we are not going to end with end statement. So whenever the statement we are going to write, okay, that statement doesn't have any begin statement with the begin. Like starting of the statement, we don't have any begin, and ending of the statement, we don't have any end. That a transaction we can call like a implicit transaction. Okay, and if the transaction is going to start with begin and like a select star from and end with end. So what are the transaction is going to start with as a begin keyword and end with end keyword. That statements we can call like a yeah, explicit transaction. So we can make a note or interview question. What is the transaction? So the transaction is nothing but a set of statement. The statement may be single statement or multiple statement. Using that statement, data can be retrieved, and we have to give the types of the transactions. Okay. Then we'll go for the asset properties. Okay. So we'll go for the asset properties. So now we'll go for the asset properties. What it is a very important. Right now we are going to go for the smaller one line or two line definition. But when we going for the performance tuning, we have to understand the more on the I. Okay. I is the very important. This I it will help. Like I can't like a isolation. This isolation will help a lot in the performance tuning, and we have to going to design the database. So the by default database having one isolation settings that will be changed from the business logic to basic logic. So here, what are the ACID properties? Okay. So whenever the transactions are, whatever the transactions are going to the our database, those transactions will follow the ACID properties. Using the ACID properties, the data will be retrieved or insert from the database to the accurate data. Okay. So now here, what is the atomicity? So here the thing is like, what is the we have a four words. Acid properties like A, C, I, D. What is the meaning of the A? The meaning of the A means like atomicity. So atomicity means like I have a 10 statements. I have a 10 statements. So while executing the 10 statements, it has to execute all the 10 statements, or maybe it has to roll forward, like a roll back. What is that means? So while executing the transactions, 1, 2, 3, 4, 5, 6, I will take 7. Okay. Instead of 10, I will take 7. I have a 7 statements. So these 7 statements I have to execute. Okay. And then I have to provide the output, or it has to store the data. So while executing the 7 statements, I executed up to 3 statements. Then remaining 4, 5, 6 statements are executing. I got a like a some power outage, or maybe that is not updated properly. So that means what will happen? It has to roll back the 3 to 1 as well. That means it has to execute all the statements, or else it has to roll back to the previous states. So what is that means like execute all or none. All means if you want to execute all the statements, that means it has to execute the statements which are in the transaction, or else it has to roll back for the statements. So that means it should not leave any transaction incomplete. So that is called like a asset properties. Why? Because in the business logic, what they will mention, update the A table, then go for the B table. Okay. Then they will go for the some business logics. So I update the A table, but while updating the B table, I got some power outage, or maybe the database corrupted something. So in scenario, what will happen? It has to come back to the previous state. So that means it should not give the uh, permanent data in the A table. So now the definition of the asset properties means all the statement of the transaction must be completed successfully or rollback completed. Means entire all none to be updated. That is the atomicity. Okay. Atomicity means like a execute all or none. That is the atomicity. Now, what is the consistency? So, what is the consistency means like when I updated the parent table, it has to updated the child table as well. So that to define the business logic. If you are not providing any business logic, that is a separate condition. But the thing is like, if you maintain the business logic, whenever we updated the parent table, it has to update the child table. So that means like it should not be leave the database middle of the state or inconsistency. Otherwise, data will be get be duplicate. Let me go for one example called like in the bank account. I have bank account A. I have bank account B. In the bank account, I am having 8,000 rupees. In the bank account, I have 7,000 rupees. In the total system, how much data we have? 15,000, 1,500 rupees. So in the bank account A having 800 rupees and B having 700 rupees. Total I have 1,500 rupees. Now what is we going to do? A is going to transfer 200 rupees from A to B. So that means 800 minus 200 equal to 600. Okay. Once we transferred, the B account should be how much data? 700 plus 200 equal to how much? 900. The total should be 1,500. So here I have a two tables like a two bank accounts. A having 800 rupees, B having 700 rupees. The total system of the data 1,500. So the thing is like A transferred the data to the B. The money deducted is from the A, but it did not receive the D to the B. Here B did not receive the data. So then what will happen? At the end of the time, we having total system having 1,300. Why? Because B did not receive the data. So here the data is inconsistent, right? So it should not be like that. Until B receive the acknowledgement, the data it has to deduct or it has to give back to A. So using the this method, the data will go for like a consistency across the like end of the time. The data should be in the consistency. So that is called like a consistency. Uh, we can convert like a parent and tail table, or we can convert like a table on A and table B, and at the end of the time, the total amount should be equal. So this entire depends upon the our business logic. Okay. While sorry, once we create the business logic, the tables has to follow the this process. That is called like a consistency. So consistency means like the transaction never leave the database of finished state. So that is means my data is detected, but the data has to go for B and it has to credited. Then end of the time the data should be 15. Here my statement executed, but B did not executed. So here my statements are not fully completed. So it is going to leave the half of the state. It should not be like that. It has to complete entire the procedure. To maintain this procedure in the background, SQL Server maintain the consistency. So now we covered the what is atomicity and what is the consistency. Atomicity is like if you're going to execute the statements, all statements should be executed or it has to roll back all the statements. Uh, like that means like all or none. So what is the consistency? it has to maintain the database in the uh, fully finished state, not for the not to leave the what I meant to say half finished state. So using the consistency, uh, it will follow the entire processor. It it will give the data as a consistency. Now we'll go for the isolation. So isolation is a very important. So in the isolation, we have a different kind of a isolations. Okay. So isolation. ISO. So this isolation, the thing is like when we creating the database, uh, we will define the isolation, and by default we will get the one isolation. Use read commit. This is the default isolation level. And the interview, it will ask while discussing about the ACID properties, they will ask what is the default isolation of the database. That is read commit. Now we'll go for the what is the exact definition of the isolation. So isolation means like we have a statements, right? While executing the statement, these statements are one transaction to another transactions are both are independent, not for the dependent. And the thing is like it should not give any false data. What is that means? Using the isolation level, the in the background database, it will provide the accurate data. What is the like if you convert the our real time in the same time, like we have a one bank account. In that bank account, we are going to deposit some data, like deposit the our amount. So while doing the deposit, what it will do? It will log the table and do the insert. Okay. So that means my account having 1,000 rupees and someone is going to deposit 2,000. Okay. So while doing the activity, if someone is going to go for like a select statement, what is that means? In the bank, in the ATM, we are going to fetch the data is like a, what is my amount? Like a, we are going for mini statement. Okay. I selected the mini statement from the ATM. But at that same time, like someone, maybe our parents or maybe any one of the friends, they're going to deposit some amount to the our bank account. That time, what will happen? That particular our bank account, which will be logged, and data will be inserted into the our uh, uh, account. So the same time, if you going for the mini statement, if you provide like a 1,000, okay, then it's a false data, right? Why? Because previously I have 1,000, but we are going to go for 2,000. But the thing is like here it may be provide 1,000 or 2,000, but it is going to provide some false data. Why? Because the thing is like if you're not going to do any locking, what will happen? It will provide 3,000, but the person in the bank account, they did not do any commit. So again, our data will show like 1,000, right? So if you're not going to put in a lab, that will maybe provide 1,000 or 2,000. Suppose it is showing like a 3,000, like 1,000 plus 2,000. That means total data will be 3,000. If you're not going to put in a lag, what will happen? Our data will show like a 3,000 in the mini statement. But in the backend, the bank people did not do the commit. Or maybe while doing the commit, their laptop got crashed. Okay. But in the same time, the other people going to mini statement as like 3,000. What we will go for impression? My account having 3,000, but my account actually having 1,000 rupees. Why? Because what are the transaction the backend people is going to do that did not commit. So here the transaction is giving a false data. So for that, if you don't want to get any false data, if you don't want to get any duplicate data, if you don't want to get any kind of a other miscellaneous. In the background, the SQL server using the isolation level. So that means by default, SQL Server database using the read commit. The read commit means like whenever the transaction we entered, automatically it will take as a commit. So if I type any insert into table, okay, here no need to put any comment. But once we execute the statement, automatically it will consider as a commit. But if you going for the Oracle, we should always keep commit. Then only our actual data will commit and our actual data go to the data file or backend database. But in the SQL Server, when you run the command and once you execute the command, no need to provide any kind of a commit statement. So what are the statement we are going to execute? That statement is like a implicit statement. So the transaction we are not going to start with any begin, and it is going to you're not going to sorry, it's not going to any commit. That is the reason of, what I meant to say. Yeah. So by default, it will take a commit. If the statement is executed successfully, then data will go to the database or disk. No need to mention any commit. By default, read commit. But the thing is like when we going for any begin, like begin, and I did not press any commit. That time the transaction it will wait for the commit. Then only yeah. So my transaction start with 1,000 like a begin, and that time what will happen? It will waiting for the commit. Okay. So that is the reason until commit completes, it won't release the lock. Okay. Otherwise, the people will get the fault data like a 3,000. Suppose in further statement is not executed. Okay. Then what will happen? The data has to roll forward, right? Like roll back, right? So that means it has to come the previous state. So in the background, it will use the isolation level. Using the isolation level, data will be locked, and by default, it's a read commit. And whenever we insert the statement will get the data. So this is the definition of the isolation level, and we are going to discuss more in the performance tuning, like a read commit, read uncommitted, and one more is like a read committed snapshot isolation level. So isolation levels are different types of isolation level. That is very important for the L2 and L3 people to explain. Why? Because using the this isolation level, we can reduce the locking and we can minimize the blocking scenarios. So this is the called like a simple concept of the isolation level. Isolation level is keeps changes of incomplete transaction independent from one another. So that means each and every transaction is kind of like a independent, not for the dependent. And if you going for the one more last, okay, what is the last one is? Last one is like a D. D means like a durability. Durability means like once you hit the call like a commit, the data has to store the permanently in the data disk. Okay. So durability is nothing but the data can be stored in the permanent. When you click the commit, the data has to goes to commit. So these ACID properties we are not going to see directly from the DB side, but this ACID properties will use from the transaction from the backend. So the application team will design the logic. That logic will follow the ACID properties. Using the ACID properties, the data will get retrieved and insert. So now I hope you understand the what is the transaction and what types of transactions we have, and what are the ACID properties in that, what is the atomicity and what is the consistency and what is the isolation level and what is the durability. And the thing is like isolation level. Right now we covered like half of the statements. Why? Because isolation levels we have a various isolation levels. Okay. So now we can go for the now actual database architecture. Okay. Let me stop the recording and we can go for the database architecture for the our further topic. Let me stop the recording.